Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just use the Q&A button. Wherever your Zoom controls are, you should see a little button that says Q&A. Type in your questions, hit submit, and I'll get to those at the end. If you're watching on YouTube, just use the live chat function wherever it happens to be on your screen, on your device. And I will get to those at the end as well. So my name is Jason Gabrinas. I'm one of Snapon's National Diagnostic Technical Trainers. Been in the training department the last 10 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snapon. So I had about 30 different franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So worked in the dealership, and I guess over time, became that default diag guy in the shop, the one that always ends up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is current probes and pressure transducers. What are you missing? If you don't have a current probe or you don't have pressure transducers, those are probably the two most common add-on accessories to go along with a scope. If you don't have a scope, then I guess you might be missing out too. But we're going to talk about some useful tests that you can do and what we're looking at to speak through a few of the different things with that. So just double check. First thing is, if we're measuring current, what is current? Or current is commonly measured in amperage. So we have voltage, amperage, and resistance, right? We have our little triad there. So voltage is a measure of the pressure that allows electrons to flow through the circuit. Amperage is a measure of the flow rate of electrons, so how much is flowing. And then the resistance is the pipe size. So if we want to equate this all to like liquid water, resistance is the pipe size. So smaller hole for my electrons to flow through, the more resistance. The bigger the hole, the easier it is to flow. If you think about just like flowing water pipes, kind of makes it a little easier to visualize the electrons flowing around and doing what they're doing. So that is what we're measuring. We're measuring current, the amperage of what's flowing through a circuit, and we can tell a lot of different things by looking at that. So the different tools of the trade that we have, this is the most common one right here. This would be our low amps probe. Goes down to about 1 milliamp, up to about 60 milliamps or 60 amps, or so. Anything more than that, you're going to want to get something a little higher. So this one I would call like a medium amp probe, if you want to call it that. They do still plug into the scope. It's got you'd have to do it on channel 1, of course, because they're right next to each other, standard spacing. But that will plug in, and that does 40 amp scale or 400 amp scale, so it gets up to 400. And then we have the high amp probe, which takes over where the other one leaves off. It's got 400 amp and a 2000 amp scale. So if I'm dealing with something that has a lot of draw, like a starter, something like that, where I need to be able to see that, we can read that with that high current probe. Now, that being said, with our scopes, if you're using this probe in the middle here, that would be on your low amp probe setting, and you just set it up for a low amp probe and you're good to go. On the other two, since they're technically designed for a meter, not for the scope, I mean, they'll work, but that's not what they're designed for. You would need to go in and use the voltage setting. So they'll put out a certain amount of voltage per amp when they read the current. So how an amp probe works overall is it will pick up on the magnetic field that will be created with the current, larger magnetic field in the circuit. They're also directional. I wanted to circle this arrow that's right here. They are directional. So if current flows in the same direction, because current can flow either way. So if current flows in the same direction of the arrow, I will get a positive number. If it flows in the opposite direction, I will get a negative number on my scale. Now, sometimes we have to flip it over, things like that. So just be aware that if you're using it and the current is not flowing in the direction of the arrow, you might have to go into the scope and invert that signal. We'll talk more a little bit more about that later. So let's talk about some things that we can do with a current probe. So fuel pump current ramp. That's a pretty common one, pretty popular one. I like this one myself because I'll tell you what, I'm not a huge fan of the smell of raw fuel. And if I don't have to necessarily drop the tank to see if the fuel pump's any good, I would rather do it non-invasively. So a fuel pump current ramp test is a good way to do that. So if you have a Snap-on scan tool with guided component test, so it'll be any Snap-on scan tool with a scope, you will be able to find a fuel pump current ramp test. Now, this is going to be for a brushed standard fuel pump, right? Not a brushless pump. Brushless pump's a totally different story. We got classes on that. You can go check those out at some other point. But inside the guided component test is going to give you, tell you where to connect. So it's going to be on one wire in the circuit. Could be positive or negative. Doesn't really matter. It can be close to the pump. If I can actually access the pump and get around the control wire for that, perfect. Otherwise, pull out a fuse, put in a jumper there, or fuel pump relay. If you got a relay for it, just pull out the relay, put a relay jumper in there or some jumper wires in there. You just want to have that around one wire. That's the important part. When you're using a current probe, you need to have it around one wire. Multiple wires can be multiple different magnetic fields. The probe will get confused and you won't get good readings. So it needs to be around one wire at a time. And then as you're doing this test, you'll see the commutator segments going by the brushes, and you'll see how the current flows up and down. Most automotive fuel pumps have 8 commutators in the motor. Some newer ones have 10. And then, of course, when we get the brushless fuel pumps, it doesn't have commutators, so it's a totally different way of talking about things. So this is just for your traditional non-brushless pumps, so brushed pumps. And what you're going to see something kind of like this. So each one of these bumps represents a commutator in the motor, one commutator segment, right? So the current flow through the commutator. Now, in this case, it's set up on AC coupling, so it just kind of centers over 0. So we'll have either side of that. It just kind of amplifies it. Otherwise, if I wanted to see how much current it was pulling, just to make sure it wasn't over current, I would turn off AC coupling, and then it's going to move to whatever current it's doing. I'll show you a picture of that in a second. But each one of those bumps is going by. You want to make sure the bumps are fairly rounded. There aren't any missing. Now, this was done on my fuel pump on my car at 79,000 miles, give or take. So we can see they got, when it's new, it's a lot more pointy. As it wears out or wears down, it becomes more rounded as it wears in. So we can see that just like that. So if we count out 8 bumps, knowing there's 8 segments in the commutators, right? So if we count out 8 bumps, that's 1 revolution of that motor. So there's number 1, 2, 3, 4, 5, 6, 7, 8, and then back to number 1 again. It's just going to cycle. Now we can do a few things in that. We can see the conditions of all the segments. The segments should kind of repeat, right? So this third one here, it's got a little extra fuzzy thing on the top. It's got a little extra fuzzy thing over there. It's the same exact one. All right. Now you can do a calculation of the RPM by counting the number of revolutions in a 10 millisecond window. I think this is one of the easiest things to do. It's just a little bit of math. But 1 revolution in 10 milliseconds is 6,000 RPM just because of math. But on this pump, it's about 1.5 times. So that means it's roughly 9,000 RPM, give or take, is how fast this is turning. And this was at an idle, maybe half a tank of fuel, something like that. So a little math. If we take the cursors and we take the difference between the two, that's going to tell me how long 1 revolution takes. So we see 6.95 milliseconds. So 1 revolution takes 6.95 milliseconds. There are 60,000 milliseconds in a minute. So if we take that 60,000 divided by how long it takes to turn 1 time, I get my revolutions per minute. In this case, 60,000 divided by 6.95 gives me 8,633 RPM. Right? So it's screaming right along. A good fuel pump, when it's running the way it should, anything from 5,000-6,000 or more, you're in good shape. Get around like 3,000 or less, you're going to have a fuel delivery problem. That could be your drivability problem right there. Fuel delivery, because pressure is controlled by the regulator. Volume is controlled by the speed of the pump. So on some newer vehicles and brushless for sure, they can speed it up and slow it down depending on duty cycle. So that would, if it needs more fuel, it would increase the amount of fuel. All right, so here is my car, 79,000 miles. Like I said, I just went out yesterday, took a new shot because it just turned 179. So 100,000 miles later, we are looking at way more round on those bumps, right? And then, as I said, if you wanted to see the actual current flow, it's maxing out at like 7 amps right here. Now, 15 amp circuit, I think we're doing okay. It's about halfway there. All right, but if it was way high and you're blowing fuses, maybe that's why. Now, if one of these was missing, that'd indicate a bad commutator segment, and that could be that no start. That's a bad fuel pump starting to fail, and you tap on the gas tank, make it vibrate, make it right. So there's one example, and that's probably one of my favorite things to do with a current probe, just test the fuel pump. Super simple. Next one, we can test the ignition coil. We can see how well it's working. So we would go on the power feed of the coil, and it should look probably something pretty close to this. So we should see it ramp up nice and smoothly. Anytime you're doing a current ramp test, which you can do on a coil or a fuel injector. I think we've got a fuel injector here next. But you should be able to see a nice smooth ramp come up. In this case, this one's current limited, so it reaches about 12 amps and then it levels off. Otherwise, it could go up and come down. We could also have a multi-strike, which would have multiples of these. What we want to see is a nice smooth ramp. If it goes up sharply and then over, that's high resistance in the circuit, probably an open, something wrong inside the coil. If I wanted to compare the current ramp to my ignition pattern, and there's whole classes that we have on ignition, so by no means is this going to be a deep dive into ignition. But you can see where the well starts on the ignition secondary pattern is where the current starts flowing in. Then the current stops once we fire the spark plug and we have that initial firing line there too. So we can see how that kind of relates. So we want to see a nice smooth ramp like that. Relative compression is another one that gets used pretty often. So you go in, you would put it around the positive or the negative cable of the battery. It works either way. And this will tell me not necessarily the pressure, but it'll tell me relative is one higher, one lower. It's using the starter motor to turn over the engine. If there's higher or lower compression, if there's higher compression, it's going to spin slower. It's going to be lower compression, it's going to spin fast. Because it's fighting against it. So here's one right here. We can see we got like an every other one. This one had an issue on one side. One bank was a little bit, was actually clogged up. We'll see a little bit later with the pressure transducer, but it's a little clogged up. So we can see the odd bank was lower than the other side as we're doing this current, relative compression. All right, so relative is one higher, one lower. Fuel injector current ramp, just like we view a coil, we can do a fuel injector. Now, the interesting thing about this is to see this is voltage, the yellow is voltage, the green is current, and then the blue is fuel pressure. So that's using a pressure probe, that's using a current probe, and this is using a voltage probe. So with the stuff that came with my tool, plus a low amp probe and plus a pressure transducer, I can check the entire fuel injector electrically, mechanically, and hydraulically just by using 3 channels and a couple probes. So here's my current ramp. It's going to come up like this. We're going to see a little dip where the pintle actually opens. So it has to charge the coil first, then it dips, and then we have it go until the fuel injector actually closes. So if we were to map this out in an animation, on my fuel injector here, we ground it, which charges the coil. And then once the coil charges, it actually opens up right there. That's where the pintle leaves the seat. It's going to have a little bit less resistance at that one point where it overcomes the spring pressure. And then the current flow is going to ramp up again after that. And then when it's done, the current's going to go away because we're not putting current through that coil anymore. And then it's just going to drop off when the injector is closed and done firing. So that's a good way you can see, once again, is it open? Is it opening? So I should see that pintle bump. Is it opening roughly the same time every time? If it's not, and it's opening like maybe down here, up there, and it's just kind of like wiggling around, you probably have a broken spring inside. It's just kind of rattling around. It's not really opening with any rhyme or reason. We want to see that consistently in the same place. We want to see consistency in the current flow at the same RPMs. If it's like 800 RPM at an idle or whatever, 700. We want to see that current flow to be about the same. Once again, if it ramps up sharply and goes over, just like a coil, got a problem in the line. So that's current probes. That's high level, a few 3-4 tests that we can do using current probes. The other thing we can do is going to be with pressure transducers, and this is going to be measuring, of course, pressure, both with liquids and gases. So in order to hook these up to our tool, we're going to need a few tools of the trade. So these are our different transducers. We got 100, 500, and 5,000. And then you also need an adapter to connect to the tool. Now, first one is going to be the split, what we call the split lead adapter. This one's actually pretty reasonably priced. It is powered by the tool. So we have that weird looking connector on the top of the tool, or if you look on, if you got a Zeus Plus, it's on the opposite side of where the connectors go, where the wires go. So that's what actually powers it. And then you can run up to 2 transducers that way as well. Now, little trick. You could run 4 theoretically, because there are enough connectors to do it. You got to get 2 of these, and then it's power. You would daisy chain it off this aux right here, power up the other one, and then run 2 more channels right there. You could do that. I don't really know of anybody who has, but it is possible. It is possible to do, because you can run 2 transducers off of that split lead adapter into there. And then we have the battery powered one too, which we call a PSA adapter. You can do the same thing with that. Since it is battery powered, actually, well, no, you wouldn't have a ground, but you can figure out how to make that work as well. Adapter 1, or pressure transducer 1, transducer 2. It's got an on-off switch, runs on a 9-volt battery. So this will work on any of the tools. What can we test? So fluid pressures, we can test fuel, transmission, hydraulics. Gas pressures, we can do exhaust back pressure or compression. Compression is probably the more popular one. But relating to what we were talking about before with the fuel injector, we can also check fuel pressure with this. So fuel pressure is going to be, as we said, when it opens, we're going to see the fuel pressure should be constant at the injector at the time. When it opens, it's going to drop. Now, in this case, it doesn't drop much. Just because it's opening for a few milliseconds. We're not bleeding off a ton of volume, ton of pressure. And then when it closes, though, you will see a little spike in pressure because it was flowing and then it just suddenly stops. So you get that little back feed into the system, and then it levels back off to where it was. Let's see. So that's the little pressure drop off there. Now, if we have a problem with the car, this is an example off a car with a problem. This is a huge pressure drop. So it's going from 60 PSI down to 30 PSI. Dropping. And it's also a 250 millisecond pulse width on the injector. This vehicle had a problem with the 5-volt reference. Vehicle thought it was really, really cold. And it was just opening the injectors like crazy, like wide. And yeah, that's how that worked. So that's just another thing you could tell with that. Check the pressure drop on that. So like I said, on a good one, it's not really going to drop much. On a bad one, it could drop a lot. And that was a no start situation in that case. Relative compression, as we did with the low amp probe, we can also do with a pressure transducer. So here's an example of a known good vehicle with relative compression. This is just, you just kind of connect it somewhere where you can get a feed off of, say, vacuum, and see how it's relative to each other once again. So in this one, this is the same one we looked at with the current probe. This is with a pressure transducer, that same vehicle that had a clawed cat on one side. So you can see the odd numbered cylinders. They're much lower than the other ones, and we can see very little in the exhaust pocket as well. This is actually very high right here coming in. So it's not as good a vacuum, or actually large pressure pulse in 135 and a low vacuum pulse. So that was indicating a clawed cat. The exhaust gas was not able to escape as well as it could. Last one is running compression. So running compression will be the usually the most popular thing that I get asked about when it comes to pressure transducers. And what we're going to see is how the vehicle is running mechanically just by using the pressure in the cylinder. So how we would do this is you're going to remove the spark plug on whatever cylinder you want to check. And then you'll use, say, maybe an adapter for a compression gauge. If you do use a compression gauge adapter, make sure you take the little straighter valve out. And then you'll attach the threaded end of the pressure transducer on the other end. And then you will start up the car and let it run. Get it captured, turn it off. You don't want to let it run for too long. You also want to make sure you disable the fuel injector somehow, because you don't want to be washing down the cylinders either. But here's an example of what it might look like. And this is on my car. It's a 4-cylinder. And this is a known good running vehicle. So running compression is going to be different than static compression. We see we get about 60 PSI at the top. And then we get a little bit of vacuum, about negative 20 PSI down the bottom. And then we have our exhaust pulses right there, intake pulse. So this is compression running up on the compression stroke on the way up. Then we ignite, and then we have it come down, vacuum. Then we have it come up for the exhaust, and then we have it come back down for the intake, and then we have our compression event happen again. So that's a good one. What's a bad one look like? Well, in this case, this one had a dead hole, wasn't building any compression at all, bent valves or something like that. This wasn't my capture. But you can see there's barely any pressure at all. A lot of vacuum, no pressure. And this one was a sister cylinder on that same vehicle. So this is what good would look like on that vehicle. So we see it come up, got a good vacuum pocket there, exhaust, intake, etc. Here's another one from that same vehicle we were talking about earlier that had the clogged cat. What would I see on that? Well, you see the compression go up, and then we have vacuum, and then we have exhaust pressure that's above zero. Exhaust pressure should not build above zero unless it's not calibrated properly. It's going to ask you anytime you connect a pressure probe to the tool whether or not you want to calibrate it. So that's what you would do. You want to calibrate it like that. So this calibrates to whatever atmospheric pressure is where you're at. So you don't want to be connected to the vehicle at that point either. So it's going to be relative to the whatever 14.5 PSI or whatever at sea level. It's going to be relative to wherever you're at. If you're in Denver, it's going to be a little bit different than if you're down where I'm at sea level. So just remember, you want to calibrate it every time. And then here is the whole deal. I'm using a voltage, current, and pressure doing this running compression test. Now you'll note how it looks a little bit different. This running compression test has a little bit more going on over here because this one the injector was on. Because I just wanted to see what is it like when it's actually running. It's not firing because, of course, we don't have the spark plug in there. But everything else minus the spark, what's going on with this thing? So this is a current probe doing a current ramp on the coil. We have compression go up, and you can see that pressure on the coil right there. Coil is actually before top dead center, which makes sense. Most vehicles are timed to fire before top dead center. So it's a few degrees before top dead center, and then it comes down. We get a little vacuum pocket. We get exhaust. We get these different pulses because it's a 4-cylinder. You get 3 other pulses. Think about that because it's open. The exhaust stroke, it's open to the rest of the exhaust, so you may get those little pulses in there as it's scavenging through. Then the injector opens. Once the fuel gets in there, my exhaust pulse looks a little bit different, right? We get a little bit more turbulence going in there. And then we get vacuum pull back there for the intake stroke. And then once that's closed, then we get our compression stroke, and then it starts all over again. So I just thought that was interesting, where we could see all of that all in one place, and we can see how it affects how the airflow goes. And this is on a Snapon split lead adapter with a 500 PSI Snapon pressure transducer. So I think that's pretty darn good detail. I think that works pretty good. There's some people say, oh, you can't use a Snap-on pressure transducer. You absolutely can. Looks just like that. I think that's a pretty detailed capture on a Zeus with a split lead adapter with a 500 PSI Snap-on pressure transducer. All right, looks pretty darn good. Looks as good as anything else I've seen with other vehicles, right? So, or other pressure transducers. So let's do a little walkthrough again. So I'm going to do a couple things this time. So first thing I want to do is let us move this over here, over to there. All right. And that is upside. Why is that upside down? We're just going to have to flip it right side up. There we go. I don't know why that was upside down. I think my phone might have flipped. I'm using my phone. But people always ask, how do I hook these things up? How do I hook up a pressure probe? How do I hook up the low amp probe, right? So I got a low amp probe right here. And got the low amp probe right there. It says Snap-on low amp probe. And we got a couple settings here. So we got 60 amp max and 20 amp max. And then you'll notice on the scale right next to it, where it says 20 amp parentheses 100 millivolts per amp. So remember how I talked about using voltage earlier. So on this 20 amp scale, each amp that this probe reads is going to output 100 millivolts in voltage. So I don't have to. I can also use the voltage scale if I wanted to, right? Then all I got to do is, this one's the easiest one, because all I got to do is just take one of these. There's the black one. Where's the red one? There we go. So we got the black and the red. Now, some people might think, oh, the red one goes in the red hole, and that's not necessarily the case. If you want to put it on channel 4, you can. But the black one needs to go to ground. Right? And you notice how it's got this extra little thing on it, so I can run grounds for voltage or something if I need to. And then the red one's just going to go wherever. If I want it on channel 1, I put it on channel 1. If I want it on channel 2, I put it on channel 2. Super simple, right? It's red, it kind of confuses some people. They think, oh, it has to go on channel 4. It does not have to go on channel 4. It can go on any of the channels on the tool whatsoever. All right, so current probe, super easy. There's also a 0 button on. So one thing, if you read the manual, so see a little button on the right-hand side says 0, right? So if you read the manual on this, and who reads the manual, but I'm going to tell you right now, what you want to do is you want to connect it to the tool, you want to turn it on, and then you want to hit the 0 button. Now, the point that they make in the manual that you might not consider is you want to have it in the same direction, orientation, as you're going to use it on the vehicle. So if you have it kind of pointed down, you want to point it down when you zero it. You want it away from electromagnetic fields. Now, why do I need to do that? Why do I need to, can't just put it up in the air and hit 0 and be done with it? It will pick up on Earth's magnetic field. So if I'm doing it like this and I'm perpendicular to the magnetic field or wherever it happens to be, and then I go down like this and it's a totally different angle, it could influence the readout of the low amp probe. Something you might not think about. I didn't really think about it until I read it. I'm like, oh yeah, that makes sense because it picks up magnetic field. So we should, a magnetic field might influence. All right, so that's the low amp probe. That one's fairly straightforward. And then we have, I don't have a split lead adapter here today, but I do have the pressure adapter, the PSA pressure adapter. So you can see we got transducer 1 and transducer 2 right there. And it's just a cable, hooks up to the pressure transducer. There's a transducer right there, right? And then it has the end on the cable. And then all I do is just plug it in. Now it's keyed, it only goes in one way. So just make sure you plug it in the right way. Little thing is on the top. Right? And then you just turn it on. The battery's dead on. You just turn it on and there you go. Now, as far as the other end, same deal as the low amp probe. They're colored differently because it was originally made to use with the 2-channel scope on the verdict. So that had a green channel and a red channel. So you do black and then whichever one you want. So number 1 is red. So if you're hooked to number 1, put number 1 right there. If you hook to number 2, you put number 2 right there. And there you go. You can work on any of the channels. Same thing. Ground still has to go to ground, of course, but they could just go to any channel. So that's how you hook it up. I always get asked, how do I plug these things in? And you never show how to plug them. So there we go. Now you see how to plug it in. So that's one thing. Let's go to the tool and talk about a couple other things. So if I wanted to learn more about pressure transducers and current probes and such, I can go into guided component test. If I have a Snap-on tool, of course. If I don't have a Snap-on tool, then we can find other resources somewhere. But in the Snap-on tool, we have these classes up here. They used to be called top-level menus. It's moved around a couple of times, but the information's in there. So I can go into classes, and if I go into power user tests, let's do current probe tests first. I'm going to select what current probe we're using, either a generic one, the older red Snap-on one or the newer black one like I have here. Current ramp testing. Then it's going to give you generally how to do fuel injectors, fuel pump, ignition coils. The manual is in here. Remember how I talked about that, right? So if we go to auto zero adjustment, like I talked about before, to adjust the output voltage to 0, ensure that the probe is away from the current carrying conductor. Connect the low amp current probe to your lab scope and select a voltage scale to view the reading. Turn the low amp current probe on by using the on-off switch, and then hold the probe in the same direction and inclination as intended for use. Press the 0 button, and then it'll zero it. But I talk about that because I think it's it's not in here. I don't remember where that was, but the Earth's magnetic field can do weird stuff. So we just want to make sure we do. Lots of stuff in that manual. And then also under transducer test. One more thing I wanted to do. Current probe. Parasitic draw testing. All right, so parasitic draw testing we can do just by using that low amp probe around the battery cable before it gets to the fuse box, and I can check the the current draw through there. It goes down to 1 milliamp. I have a 1 milliamp draw. I'm not going to be all that concerned. All right, so that's probes, and then we have pressure transducer tests as well. There's a couple different tests that we can do: exhaust back pressure, fuel pressure, AT line pressure. But if I go back here, oops, too far. If I go back to my how-to section, there is, if I can find it right here, 10-minute running compression waveform. So this will tell us all we need to know. Everything I kind of just told you really, really condensed. If you wanted to read about it, you can go in here and read all about it. It's going to tell us what we see. It's going to give us the little ups and downs there. I think there's another one in here too that I saw earlier. We go on the test tips. There might be something there too. Parasitic draw again inside there. Using pressure transducers. A couple different tests you can do there. Snapon transducer is going to tell you how to work. So a lot of information built into the tool already. The manual for the low amp probes in there. There's all sorts of classes on that. There's classes on current probes too. And then if you go into guided component tests, it's going to show you how to do current ramp test in there as well. Presets, all ready to go. All right, then one more thing I just kind of wanted to go over was the this pressure transducer test that we talked about, right? So this is a capture that I did from that screenshot that we saw before. This is open in Shop Stream Connect. So if I wanted to capture this, save it, and then play it back later, I can do so. And then we can see, here's my pressure. Here's my fuel injector. I can just kind of move that up out of the way. And then here's my current. So we can see where it fires. Where does that coil fire? So it's right there. Turn on my cursors here. So where's my coil fire? So that coil fire is right there. And I don't reach top dead center till right there. So that's a few degrees of travel. If you wanted to do the math, you can figure out pretty much how it's going. From there to there, it's probably maybe 10, 15 degrees at most between there and there. How would I do that though? Just real quick math rundown. So if I want to bring it at top dead center here, and I want to bring it at top dead center here. Come on. And then pull up the math here. So that's 200 milliseconds. That's nice. It makes it a lot easier. Being exactly 200 milliseconds, the math works out. So it's 50 milliseconds per stroke, but it's 720 degrees. So it takes 200 milliseconds to travel 720 degrees. We should be able to, if I can pull up my calculator here. There we go. So if it takes 200 milliseconds divided by 720 degrees, it's 0.27 milliseconds. So per degree. So there. Go to there. All right. Oh, wait, I'm sorry. No, that was 200 mils time scale. What am I doing? Yeah, my math's going to be wrong because I didn't pull up my measurements. I was looking at the wrong screen, trying to do all this at once. Okay, so 132.55. So 720 is no, that's the wrong one. 132.5 minus 720. There we go. 0.18. So if I go over here and I go over here, you get 3.89. 21 degrees. I was wrong. 21 degrees before top dead center is not that far. So there's your math. All right. So we can see, there's the exhaust. Like we said, once the fuel injector fires, it does some, creates some swirl in there because we got some valve overlap. Lots of stuff that you can see. And like I said, we have a couple whole classes just on pressure transducers and doing that. And there's tons of information out there. I just wanted to key you all in on a few different things that are available to you out there that you might not have been aware of that are available to you. So with that, that's my time for tonight. Let's talk about next week. Next week, we are continuing our batch of new classes that we've been going through. This is class number 2 out of 5. Next week will be a diagnostics comparison, because I get asked questions on this a lot too. Medium duty versus light duty versus heavy duty vehicles. What's the right tool to use? Are the codes different? Is it structured differently? Yes. Might I need different tools? Possibly, depending on what you're working on. So we'll cover those different topics next week. Same time, same place, 6 and 9 Eastern. Go to snapon.com/OT if you want to watch it on Zoom. Otherwise, the 6 p.m. Eastern class goes to YouTube. If you're watching on YouTube, please thumbs up, subscribe, ring the bell, all those good things. And then 9 p.m. Eastern goes to my Facebook page, facebook.com/SnaponJason. And we can see you there. If you want to see any of the previous topics in this series, we do have one just on pressure transducers. We have one just on current probes. If we got a couple different times we talk about current probes as well. All available for free on our YouTube channel, youtube.com/Snapon Diagnostics. Anything from ADOS to thermal imaging. We got 68 episodes. This is episode 69. We're recording right now. So all available for you any time of day for free. Now it's time for Q&A. If you do have questions and you're on Zoom and you join late, just use the Q&A button, and I'll get to those in a second. If you're on YouTube, just make sure that you use the live chat, wherever that is. I also want to remind you before I get to questions about my buddy Keith. So he does free training as well, Wednesdays and Thursdays. Wednesday is on Zeus Plus, and then Thursday is on Apollo and Triton. It's going to go everywhere from setup. Let's make sure your Wi-Fi is set up and working. Let's make sure you're set up with Snapon Cloud. Let's talk about Security Link. Then he goes through code to completion, fast track intelligent diagnostics. On fast track intelligent diagnostics, shows you how it's going to help you. And then also takes about a 5-minute break after that. That's about the first hour. And then for another 45 minutes or so, he goes over the guided component test, scope, meter, all those different functions as well. It is Zoom only. This is designed to kind of be sitting in front of you with the tool in front of you, follow along with what he does on the screen. So snapon.com/OT to sign up and reserve your spot for that. All right, let's go to Q&A. Got a couple on Zoom. Gerardo says hello, welcome. Thank you. Let's see. Will's got a long question. Let's see. He's got the ETA 502C, which is one of those non low amp probes to high amp probe, I think. And using it with one of his digital multimeters, given the negative and positive are tied to each other on the clamp, and the ground and amp jack are not next to each other on the meter. How do I get this to work? Product does say it's for use with that meter. So what you're going to do in that case, because the amp on the meter, I don't have a picture of one in front of me, but you're right, the amp and the ground are not together. So on that meter, on those meters, when you're doing amp, that's meant to be an inline current, right? So you'd separate the circuit, put positive or, 2 of the leads in between. It's meant to run in line. if you're using the low amp probe, high amp probe, medium amp probe, whatever, where they're two tied together, you're going to put it on positive and negative because those are the two that are right next to each other, right? And then you're going to put it on voltage. And then you're going to use whatever output voltage, like we discussed earlier, right? So on the low amp probe, it was what, 100 millivolts per amp on the 20 amp scale. So those other probes tell you what the volts per amps could be, 100 milliamps, or it could be 10 milliamps, whatever it happens to be per volt. And then you just have to do a little bit of math using the clamp. So it's compatible because it'll plug in, but it is not going to read on the amp scale. You have to read it on the voltage. I hope I explained that as well as I could. Just because, and that you'd have to do that on the scope as well. All right, let's see. On YouTube, hello, Teller Automotive. Quinn, welcome. Thanks for joining. Colorado Automotriz is what it is. It's from Mexico. Welcome from Mexico. Rock Punk Dad made those images for the component test meter when I worked for Snapon Diagnostics years ago. Yeah, thanks. We're still using them today because it still works. It's still the same, right? Donald Hopkins, welcome from Northwest Ontario. Welcome. DJ, thanks for joining as always. Mark, hello. Quinn says hello to DJ. Nick, welcome from the UK. Thanks for joining us. I did see the comment about the subtitles, right? So Canal Mechanica Pagliarini, I think I pronounced that right. But he says, please turn on the subtitles for live. YouTube is very limited in subtitles. And then once it processes with live as well, there's only a couple languages that YouTube does. It's a YouTube thing. And it's not, I can't turn it on or off. It's just when YouTube doesn't process it the way that's just how it goes with YouTube. So it's a source of frustration for more than just you. Right. Let's see. Quinn says GDI as well. So GDI, you were talking about the fuel injector, right? So you will see the pressure drop. Pressure is going to drop so quick, though. Might be hard to catch a lot of it. As far as current, the current pattern is going to look totally different because you're usually like peak and hold, and it's like a pulse width modulated signal. So the current flow is going to look a lot different on GDI. And there's two different types of GDI injectors as well. Keith says, hello, welcome. Donald's excited for next week to go see medium and heavy duty. Said it should be a banger. Nick says, have a good weekend. Can't wait for next week. And Anthony says, good presentation. Thank you. And Jesse chimes in from Florida. So welcome, Jesse. Thanks for joining us. All right. Will commented on Zoom that he got it. Hopefully I explained it well enough that he understood it. And yeah, so it looks like we are clear of questions and comments. So with that, I'd like to say thank you very much. Thank you for taking a little bit of time out of your day, spend a little bit of time with me. Hopefully you learned a few more applications that you might not have been aware of with current probes and pressure probes. Hopefully we'll see you next week for medium duty diagnostics. With that, enjoy the rest of your night. Enjoy your week. Enjoy your weekend. We'll see you next week. Have a good night. Take care.